Okay, I'd like to spend a few minutes talking about box plots or box and whisker plots. But let's spend a few minutes just talking about the plot itself, the interpretation. So a box plot is a graphical method of representing summary measures. And that's partly why we're talking about it here with descriptive measures, because it really just takes the summary measures that are calculated or can be calculated on for a set of data and presents those in a visual way. So what you're actually seeing are summary measures on the plot and not actual data points. So we can use it to describe a single variable in a data set or to compare multiple variables. And they're quite useful, and you'll see them often presented in different contexts. So I thought it's probably worth spending some time talking about here. And this chart shows you some of the measures that are displayed in a box plot or box whisker plot. And they're, depending on how advanced your routine is for generating these, you may see more or less of these observations, of these summary measures, but at very least, it allows you, the box plot allows you to see the mean, the median, the first and third quartiles, and something called the interquartile range, which is the distance between the first and third quartile. So when you observe the first and third quartiles, you can simply look at the physical distance between them measured in the scale of your variable, and that'll give you something called the interquartile range, which is another measure of the amount of distribution or the amount of spread that is in the data. Not as commonly used as the variance and the standard deviation, however. Some other measures that you might see are called the outer fences, the inner fences, and so on. And where these come in is that the box plot, in its most formal sense, really measures things in terms of that distance between the first and third quartile values. And this is a box plot for a set of data. And just to point out what you would see on a typical box plot, the horizontal axis is the axis of the variable in question. And the box in the middle is the box that gives it its name. And the horizontal lines going out to the left and right sort of resemble whiskers if you imagined you were looking like straight on at the nose of a cat or dog or some kind of animal, right? I guess that's where the box whisker name comes from. And here are some of the measures. The box in the box plot, it really shows you where the middle 50% of the data falls relative to your horizontal axis. So the left-hand side of that box is the first quartile value if you were to read down to the horizontal axis. The right-hand side of the box is the third quartile value. So in between those two would represent the middle half of the data, the middle 2/4 of the data. Often there is represented, there is a vertical line somewhere inside that box, which represents the median value. Here it's roughly in the middle of the box, but it's not always. And you can read vertically down to the horizontal axis and pull off that median value from the data set. The other thing that you will see sometimes inside the box or near the box is a single point representing the mean of the distribution. Some routines, some methods of generating box plots don't actually show you the mean, but certainly the quartiles you'll see, and the median value sometimes. In most routines, the method I'll show you that you can do in just raw Excel doesn't actually generate as much detail, but does give you a sense of the distribution of the data. Okay, so the width of this box, as it's shown here, represents one interquartile range. That is the distance between the third quartile value and the first quartile value. The horizontal lines going out, the whiskers, start from the third quartile value and go up 1.5 times the width of the box. So 1.5 interquartile ranges or up until the last data point, the highest data point. So if your highest data point fell somewhere in here, then this whisker would stop at that highest data point. If you have data values that are higher than 1.5 interquartile ranges above the third quartile value, those actual data points are shown, and those are outliers. And those outliers are actually the only data points that are shown on a box plot. Any outliers you might have, any points on the high side or on the low side that are more than 1.5 times the width of the box, 1.5 interquartile ranges away from the box. Okay? And that boundary, 1.5 interquartile ranges below or above the box, is what's called the lower fence, or the inner fence in some cases. The inner fence on the high side and the low side. So you may see the upper inner fence value and the lower inner fence value. That's just the third quartile plus 1.5 interquartile ranges, or the first quartile minus 1.5 interquartile ranges. And anything outside of those, of that inner fence value on the high or low side would be outliers. Another distinction that is sometimes observed is that if you have extreme outliers that are very far away, they're called extreme outliers, and they're often represented a little differently. One might be mild outliers, as these are called, might be open circles or open squares, and extreme outliers sometimes are shown as shaded or closed, filled-in circles or squares. In this case, these are all mild outliers. And the break point between mild outliers and extreme outliers is another 1.5 times the width of the box. Another 1.5 interquartile ranges away from the third quartile or the first quartile, respectively. And those boundary values are called the outer fences. So you have an inner fence value where the whisker stops if there are outliers, and an outer fence value, which is the breakpoint between mild outliers and extreme outliers. Now that's a lot of information, and what I've done here on these these next two slides are really to capture all that information, but you can read more detail about box plots. But very often you can get, let me go back a slide, you can get a sense of what the distribution looks like just from looking at the plot without necessarily knowing the details of where the fence values are and things of that nature. If this distribution, for example, if you were to also generate a histogram for this same data, would be pretty symmetric. Okay, the mean and the median are very close together. The median is roughly halfway between the first and third quartile values. The whiskers both go out to full length, 1.5 interquartile ranges, and there are some outliers on both sides, and they're roughly balanced. They extend out a little further to the left, and it seems like there's more of them to the right. They are more tightly clustered together to the right. So if there's any slight skew here, it would be in the direction where the outliers tend to pull further out. And that's why the mean is slightly lower than the median. But they're so close together that I would call this virtually symmetric. Okay, and you can get this picture from looking at just looking at a box plot without too much detail. So sometimes even the crudest methods of generating a box plot can give you some good information. Okay, so these slides give you some text of what I was just saying about interquartile ranges and so on, and mild and extreme outliers.